This is Tony Cox. Thank you for spending a few minutes with me today to talk about the important topic of communicating about the human health risks caused by air pollution more accurately. What the public often wants to know, and what individuals often want to know, is the answers to questions about how big is my risk from air pollution? How sure can I be? What can I do to reduce it? And what can other people, such as the operators of coal-fired power plants, what can they do to reduce my risk? How much difference would their actions make? How effective have they been in other countries and for other people? How do we know how effective these actions would be? That last set of questions is sometimes referred to as accountability studies. The current state of the art, as I understand it, is that despite many claims, it is not yet known how much and for which people reducing air pollution causes reductions in death rates. What is known is that there's a statistical association between higher levels of air pollution and higher mortality rates in many countries, both within countries and between countries. But there are other factors, such as very prominently income, and also education and nutrition, employment. There's a whole cluster of factors that tend to be different between people with longer life expectancy and people with shorter life expectancy. Higher pollution is associated with lower income and with many other things. But which of those variables needs to be changed in order to protect public health is not well understood as yet. So the question of how air pollution health effects depend on age, income, local temperatures, and other variables is still being clarified. Policymakers, in addition to needing to know the same kinds of things as other people, also need to know how much health harm in a population could be prevented by policies that reduce exposures. And the answer to that is usually given by quantitative risk assessment in the terms of changes in the probability distribution of number of adverse effects per person per year as exposure is changed. Accountability studies, which look at what's actually happened when exposure has been reduced, can help to reduce uncertainties as well as to answer questions about the effectiveness of different policies. What policymakers are usually told is something different. They're told how big the estimated risk attributed to or blamed on air pollution is today. That's a different piece of information from answering how it would change if policies reduced air pollution levels. It's not the case that blaming air pollution for a certain number of deaths implies that if air pollution were reduced, those deaths would not have occurred or would have occurred more slowly. So in general, attribution and blame for risk is based on statistical association, but prevention of risk is based on causation, and those are two different concepts. They require different tools. An example of current risk communication from this month is shown here. It's the Air Quality Life Index. This looks at how life expectancy varies and from country to country, and tries to connect that to variations in air pollution levels from location to location. And there's a very dramatic set of headlines that's been going around much of the world recently. An example is given at the bottom of this slide. It says the particulate matter air pollution cuts global life expectancy short by nearly 2 years per person. And of course, that's a very sensational finding. It should not be thought that what this means is that if we didn't have air pollution, people would live 2 years longer. That would be a causal claim that has not yet been found to be true. And in fact, as we'll see shortly, there are studies in which quite dramatic decreases in pollution have not produced any such change in life expectancy. The supporting analysis is quite detailed, but it comes down to comparing life expectancies on two sides of a river, a river in China where there was higher pollution on one side and also shorter life expectancies, lower pollution on the other, and perhaps longer life expectancies, depending on exactly what models are fit to the data. If one fits different models, one would get very different answers. But the authors selected a particular set of models and estimated that there was a jump from one side of the river to the other in life expectancy and in air pollution, and they assumed that there was a cause and effect relationship, that it was because of the change in estimated air pollution levels, or estimated average air pollution levels, that there was also a change in estimated average life expectancies. A different possibility would be simply that both of them are different in different locations, and not because one causes the other. But the authors assumed that there was a causal relationship and that the same causal relationship would apply worldwide. And that was the result that was communicated to the public. Now, there are a number of unknowns in this study. One is what actually caused the differences in life expectancy. Another is how would changing exposures change life expectancies. The authors used a statistical model to guess at the answer, but no one knows whether the statistical model is plausible. The exposure and response curves didn't really have the same shape. It's not clear why they didn't match each other, so that's an unknown. And it's unknown whether these relationships actually hold anywhere else, or whether they hold at lower concentrations, or for different income groups, or whether they hold for true exposures as well as estimated exposures, which can be quite different, or whether there are thresholds. So there are a number of scientific questions that were not answered, but assumptions were used to extrapolate from the two sides of the river to the rest of the world. This illustrates, I think, some challenges in communicating air pollution health risks accurately. One challenge is that we want to make sure that we're communicating facts and not assumptions, or not a mix of facts and assumptions that the audience is unable to disentangle. So the headlines that report that people would live two years longer on average if only air pollution were reduced typically don't report that that's based on an assumption from a study that fit a particular model, a particular set of assumptions to some local data around one river. Secondly, this raises the challenge of how to communicate without overstating results and without exaggerating or manipulating the presentation of results to suggest more than has been shown. For example, headlines of the form "Air pollution kills millions worldwide" certainly grab attention for policymakers and the public, much more than the less sensational headline that there are higher death rates in pollution north of a river than south of it. That second statement is what was actually shown. The first statement is a large generalization from what's actually known. Thirdly, there's the ambiguity of causal language. It's a fact that the statement "air pollution kills so many million people each year" does not imply that if the air pollution were removed, then those deaths wouldn't occur. In fact, in a population of a fixed size, the death rate in any year must be equal to the birth rate, or the birth rate some time ago, and that's not affected by pollution. But those kinds of nuances, which are very important for understanding what we can change and what we can't change, are lost in this communication that's not very carefully framed and presented. So fortunately, there have been some accountability studies, many of them led by the Health Effects Institute, HEI, the Health Effects Institute. An example is a study of coal burning bans in Dublin that showed a very large reduction in air pollution, something like a 40 to 70% reduction in particulate air pollution, and yet no detectable reduction in total death rates. This is a very interesting finding. It's a curious finding. It's not clear why there was no reduction in death rates, but it illustrates the idea that the simplistic proposition that reducing particulate air pollution causes reduction in air pollution everywhere, that's a universal law, does not appear to be true. And so that invites the question of, well, for whom is it true? Where is it true? Under what conditions? Quite different from communication among scientists. And this leads to the question of how we can do better. And I think there are four principles that I'd like to leave you with. One is that we should be much clearer in our use of causal language. We should stop treating statistical associations as if they were causal relationships. Instead, we should put great emphasis on the results of valid accountability studies. If the accountability studies show that pollution went down and that mortality didn't, then that should be stated. If it showed that pollution went down and mortality then went down faster, where pollution was reduced than where it wasn't, then that should be stated. So clarifying causal language and making good use of accountability studies can help us to be much clearer about what is actually known about the health effects of reducing air pollution. Secondly, we should resist overgeneralizations of the type that are currently being circulated based on the Chinese river study. Thirdly, assumptions and uncertainties should be clearly stated. So if we're going to assume that what's true on the two sides of a river also holds worldwide, then that assumption should be stated rather than just showing the resulting numbers as if they were known to be correct. And finally, we should present alternative conclusions for different plausible assumptions. So if a different assumption is that the cause of a decline in death rates is improvement in income, which might go along with reductions in pollution, then the results from that set of assumptions should be presented right along with the results from assumptions that it's only changes in one factor, such as air pollution or income, and not the other, that explains the reduction in mortality. Okay, finally, there are a number of techniques, which I'm not going to describe now, but which are described in the literature and in recent papers, including some by me. There are a number of techniques for using data to explicitly show the causal network, the network of causal relationships among variables. And methods that use these networks can be tremendously helpful in clarifying exactly what effects are being quantified, how strong those effects are. So scientists have available to them a number of ways for being more precise about the effects of changes in exposure on changes in risk, and should certainly take advantage of those methods. To wrap up, what do we actually know now? I think what we know is that air pollution is associated with lower incomes and higher death rates, both within and between countries. Several completed accountability studies have not shown that even large reductions in air pollution actually cause reductions in death rates. So why not is an interesting scientific question. The answer is not yet known. To my knowledge, we don't yet have a good set of accountability studies that reveals who benefits in terms of increased longevity or increased life expectancy, who benefits from changes in air pollution or reductions in air pollution in the absence of changes in other factors, such as income, most prominently. So that's a worthwhile area of research. In conclusion, to better inform decisions and also evaluation of actions that regulators or policymakers might take, the most important things to do are to clarify causal language, not to confuse association with causation. Don't overgeneralize from limited data. Don't make strong policy claims unless they're backed up by accountability studies. Secondly, distinguish between estimated and true exposures, because the apparent causal relationships between changes in exposure and changes in response can be very sensitive to whether the exposure estimates are correct. Thirdly, state assumptions. Fourthly, admit puzzles where there's a something that's not understood about the data, and failures. For example, in Dublin, it's from those unexpected findings that we potentially learn how the world works and how we can do better. And finally, conduct and report results of valid accountability studies. Those can help us to be much clearer about what really works and what doesn't. Thank you so much for your attention. I look forward to your comments and questions. You can reach me at this email address, and I appreciate your time.
是跟低收入、跟贫穷、跟高死亡率都有关，就是在全世界都这样。如果收入高，死亡率就低。所以世界卫生组织说，空气污染会杀死700万人，但是他说，降低空气污染不一定能救到1个人。就说你可以说。空气污染杀了那么多人，因为它附带贫穷，它附带低收入，附带高死亡率。但是你如果减少空气污染，对于执政者来说，应该要非常小心，它不会减少死亡，这是它最重要的一个结论。大家对这样子的结论，就是说，单方面。我们普通都是单方面有它的因果关系，但是如果把它倒过来，除非你能验证出来，但是我们现在从来没有人验证过说把空气污染变好，我们的死亡率会减少，没有人这么证明过。所以这个是我们的这个 Tony Cox 的一个很精辟的演讲对于关于空污的风险沟通。